Hi, I'm Chris with BuildSharper.com. So today I wanted to share one of the videos in our series on programming fundamentals. This course is designed for someone who's never really written a line of code before. And we cover variables and data types. So this beginner lesson is designed to give you an understanding of how applications are written and how data is stored and manipulated throughout the application. And again, if you like this kind of content, please like and subscribe, and then hop over to BuildSharper.com. Right now we're running a special. If you sign up, you're going to get a free 40-minute one-on-one consulting call to get you started. So without further ado, let's get into it. Welcome, builders, to Programming Fundamentals. This is going to be a series of courses that is mostly designed for those of you that have never written a line of code. It's to teach you the basic building blocks of programming so that you can move on to the other more advanced courses. But this will kind of teach you how programming languages work under the hood and how things are structured. Specifically, today we're going to talk about variables and data types. Okay. So, as I said, variables are something that change in the application. So once you compile a program, there are portions of the code that are what they call hard-coded that aren't going to change. But there are other values that do change. So for example, let's say you start up a website and it says, "Hello, Chris." Well, it's not hard-coded to say "Hello, Chris." It's coded to say "Hello, name." That name is a variable because it's coming dynamically as the application's running. It's going to populate that value in real time. So let's look at an example. So let's say, like we said, let's say in our program it says hello, and then we wanted to say somebody's name. This portion is going to be a variable. So the text hello represents the hard-coded value in the application. So that doesn't change. But the person's name, hello Chris, this has to change. So I can't hard-code that. I have to put it in a variable, something that can change. The value of the variable can come from anywhere. It can come from a database. It can come from the user's input. It could come from a file. It could come from the cloud. It could be populated anywhere. So now that I have this variable, I can reuse this value elsewhere. So in this case, it said, hello, Chris, with their name. So then now I know this person's name is Chris, and I can call them Chris throughout the application. So I could do something like, wow, my favorite name is, and then I could reuse this variable here. So I'm trying to figure out visually a way to put that, but basically here would be the value of this variable that I could populate dynamically in this area. So let's say Chris. And we wanted to end with an exclamation, with a bunch of exclamation points. The cool part is I can then also ask them to change it. So using this same variable, I could have, for instance, what is your name? And then with this variable, we're going to visualize this a little bit. We're doing this in real time here, so bear with me. So I'm going to point this around here. Okay. So this is the variable with the square. And then the rounded one represents the use of that. So let's say we ask them, what is your name? And then we're going to do another display up here. So can we do this? There we go. So there you go. They enter their name once here, and we can reference it multiple times. So if I'm asked, what is your name? And I said, Fred. Now, every time I reference that variable, it's going to give me the new name. So, Fred. So we can see variables house data, and this data could then be used throughout the application. Now, a little bit later in the lesson, we're going to go over data types that talks about the types of data that are in these variables. But for now, let's keep it simple. Let's just go with strings. A string is a series of characters. So let's hop into an application. So if you go on to the github.com/buildsharper repo, you'll see that we have Course 101. You'll want to go ahead and clone this repo to your local. If you need help doing that, go back and watch Course 0. There's a tutorial on setting up source tree and kind of an overview of Git. And if you have more questions on Git, we have a course just dedicated to Git itself as well. So go reference those if you have any questions. But for now, I'm going to assume that you know how to pull down the code and clone it. And we're going to hop into Visual Studio. Okay, so we've got our course pulled down. And I've opened up the buildsharper.course101 solution. We can see there's two apps in there. There's this app 1 and app 2. We're going to get to app 2 in the next section, but for app 1, open up the program CS file, and you can see it says, let's play Build Libs. So the way I try to think of this is, remember as a kid, did you ever play Mad Libs, where you, on a piece of paper, you are asked a series of questions to fill in words, such as name a proper noun, or an adjective, or a plural noun, or a verb ending in ed. So you populate all these words, and then those words are a part of a story, and they're populated into the story, and it's silly because it doesn't contextually make any sense. But essentially, a Mad Lib is a great way to visualize variables, because each of those words you fill in is a variable. Okay, so we're in program.cs. We have a little header here, let's play Build Libs. It's going to ask the user for these values one at a time. So let's look at lines 5 and 6 here. So console.write, enter a name. And then we're doing var name equals console.readline. So what that's doing is it's creating a cursor and it's awaiting input from the user. So console.write means it'll write out, enter a name, and then the cursor will be right after that colon, waiting for the user to type it in. Once they hit the enter key, the value that they have typed here will go into this variable called name. So we have variable name, then you can see we're asking them enter an adjective, and whatever they type, this read line goes into adjective 1, and so on. Then down here, we can see we're going to do a write line with the story. And embedded in this story are these values that we're capturing above. So for instance, we can see, come on over to names pizza parlor. The value of name was specified up here when we asked them to input their name. Okay, so let's run this and take a look at it. Okay, so we got the app open. Let's play Build Libs. Enter a name. Chris. An adjective. Handsome. A noun. How about a fork? Another adjective. Giant. A food, plural. Peanuts. A noun, plural. Ladders. A verb ending in ed. Warped. Liquid. How about coffee? Everybody likes coffee. And a noun. Trash can. Okay, so come on over to Chris's Pizza Parlor, where you can enjoy your favorite handsome dish pizzas. You can try our famous Fork Lovers pizza or select from a list of giant toppings. including sauteed peanuts, ladders, and more. Our crusts are hand warped and basted in coffee to make things seem more trash can made. Wow, that worked out. So press any key to continue. And that's it. Now we're back into Visual Studio. So now, as you can see in this code, everything we have is called a var, or a variable. So this is a more advanced data type actually, because it assigns the type at runtime. At compile time, when we build the application, .NET and C# actually don't even know what these values are. We want them to be dynamic, as whatever the user types, it's going to take that value and store it. So, for instance, if we were to ask them their age, we would want that to be a number. We wouldn't want them to put Fred for their age, right? So in the next section, we're going to talk about data types and how that works. Okay, so we just learned what variables are. It's basically a way to store data within the application and then use that data to make decisions within the application, to display the data. Variables are basically the foundation to how applications run and how logic is determined. So, as I said, with a variable, we're storing the data, but to use it effectively in the application, we need to know what kind of data is in there. So in the example with the Mad Libs, everything was a string. A string is basically just a word or a series of characters. But imagine if a student record had to be stored, and based on that student record, we had to make decisions. So we might have data like whether or not the student is enrolled. So that would be a true or false value. Or we need to know how old they are. Or do we need to know their date of birth? All of these are specific types of data that our program needs to be able to make decisions on. So let's take a look at data types. So I'm going to go back to my browser and go back. So let's delete this example and we're going to go into another example. So as I was saying, if we have a student record, we need to know certain things such as whether or not they're enrolled. That can be a simple value of true or false. In programming, if we only want to know true or false, that's called a Boolean value. So in .NET, that data type is Boolean. So, and in that, Boolean, this value can be true or false. And an example of this would be, example, is enrolled. Okay, so is this student enrolled, true or false? That would be stored in a Boolean value. Then, let's say I need to know what the student's age is. That is going to be stored in what we call an integer. An integer is a numeric value and a whole number. So there are no decimals with an integer. And it in .NET is called an int, of type int. So the value there is going to be numeric. So let's say 25. And we can use the example as being the user's age. Okay? Now, let's say we need another numeric data type. So let's say we need to store their GPA. Well, a GPA you can't store with an integer because it has to have a decimal value to it. So in C# and .NET, the decimal variable type, data type is called a double. So let's go down here and create a double. And the double we're going to use to store the GPA. So let's say, for example, a double would be like 3.7. And this is an example of GPA. Okay? Now we have simple true or false with a Boolean. We can store a number with integer, and we can store a decimal value with a double. But now what about, let's introduce characters. A character would be a single letter that we need to store. So for example, on a student record, we might store M or F for male or female. So let's take this over here, and this is going to be a car is the variable type, or char. People call it either way. I call it car. Some people call it char. And that value is going to be a single letter. So in this case, we'll use M, for example. Let's say this is a male student. And the example here would be sex. So related to that is what they call a string. A string is a collection of characters or text. So let's go create our string variable. So we're going to go in here and create our string. This goes here. And an example of this would be their name. So let's say Chris. And this is an example of their name. Okay? And finally, the last data type we're going to cover in this lesson is the date time object. So let's say we needed to store their birth date. Well, that would be the date time object. So let's pull this here and create a date time. And this value, we're going to take a look here. So let's say they were born May 4th. May the 4th be with you. Hey, I got my Star Wars shirt on today too, so that fits. Okay. May the 4th, 2000. And let's say an example is their birthday. Now, the one thing I'm missing here in the date time field is that it stores both the date and the time. You can change the display to be whatever you want. You can actually have it only display the time or only display the date. But structurally, inside of the variable, it's going to store both the date and the time. So even if I didn't enter the time I was born, it's going to store 12 o'clock a.m. as that default value. Or if I knew I was born at 10:30 p.m., we could put that in there as well. So these are our strongly typed variables now. In the first section, we were just worried about strings. We only had words, whether they're nouns, adjectives, names. Those were mostly just strings or this type. That's what we worried about in the first lesson. But now we want to have more structured data for these student records so that we have the ability to make decisions based on that data. So let's say if their GPA is below a 2.5, then we have to have some sort of message on screen that says, something about their grades. Or if their GPA is a 4.0, maybe we want to have like a congratulations thing pop up. Or if they are not enrolled, maybe we show them a registration page. Or if they are enrolled, maybe we show them their courses that are available. So based on this kind of information, our application can make conditional logic decisions around that. So based on this, we're going to hop back into Visual Studio and we're going to take a look at that second app. Okay, so I'm jumping back into Visual Studio and I still have app1 selected. So I'm going to expand app2 and go to Program CS. One thing to note real quick is you'll see app1 is still in bold and app2 is not. The bolded application is the one that you're going to run by default. So up here, when I run this, it's going to run the startup app, which is the bold one. We now want app2 to be our default. So we're going to right click on it and go down to set as startup project. And you can see now it's bold. So if we were to run it, we would be running app2. So now let's take a look at the program CS file. So immediately what we'll notice that different here is look at these types. So remember in the first program, everything was a var. And as I said, that's a generic way to label a variable. Is we don't really know what kind of data is going to go in here, but it'll be determined at runtime when the app is running. But if we want to have strongly typed variables, we can declare them this way. So bool enrolled is true. I've got a first name, a last name, sex is set to male, age 21, GPA of 3.7, and I'm specifying a birthday. So the neat thing about strongly typed variables is they ensure that they have the right value in there. So, for instance, bool enrolled equals true. You know, this could also be false if I didn't want them to be enrolled, and that's valid. But I can't say bool enrolled equals 1, 2, 3. So if I go to try to run this, if I do a build, the build failed because it says cannot implicitly convert type int to bool. So on the right side, this 1, 2, 3, that's an integer, right? So that's int 1, 2, 3 trying to be put into a Boolean variable. Well, Booleans can only be true or false. So the compiler doesn't allow this. You can see the red squiggles under it, and it doesn't allow it to go through. So let's see, if I do true, now it's happy again. Now with this next value is a string. As we said, that's a series of characters, and they're surrounded by double quotes. So anything within double quotes is going to be treated as a string. So since this is a variable of type string, I can't put the 1, 2, 3 here either. Now we get a new error. Cannot implicitly convert type int to string. So we have this string called first name, but I'm trying to put an integer value of 1, 2, 3 into that string. It doesn't like that. The compiler is going to complain about it. So now, as we said, a string is surrounded by double quotes. So if I wanted to put the string 1, 2, 3 into the string variable, I have to surround it by double quotes. Oops. So I can put quotes here and here. So I've wrapped that 1, 2, 3 in quotes, and now the compiler's happy because this is a string, right? So I'm going to set this back to John for our purposes. And that would be the same for last name. Now we're moving on to car, which is a single character. So we can see instead of double quotes, this is wrapped in a single quote or a tick. So, and this only allows one character. So, for example, if I wanted this to say, if I tried to put male as a car, it's going to complain because there's too many characters in the literal. That's a obscure way of saying you can't have a string here. It needs to be a single character. So, and even if we were to wrap this in double quotes, it's going to be the same thing. If I try to put male, now I'm going to get cannot implicitly convert type string to car, because again we have a car variable and we're trying to put a string inside of it. You can't do it. So let's go back and put this as the M car. Okay? Next is age. So we're putting the value 21 into an integer variable called age. And if I wanted to say, well, what if they're 21 and a half? It's not going to like that. It's going to say you can't put a double inside of an integer variable. So you can see with these strongly typed variables, it helps ensure the validity of the data. We can trust that the data that's in there is what we're expecting. So if I have logic that says, if the age is over 21, make this happen. But if their age is equal to Fred, well, then it doesn't know how to compare that. So with a strongly typed variable, I know what to expect. So in this case for age, I know it's an integer and I know I can compare it. So I can say if its value is greater than 21, make this happen. And finally with the birth date, we're setting up a date time and we're doing a datetime.parse. Don't worry about this yet. Essentially it's taking a string value of 3/11/2001 and it's converting that into a datetime object so that the raw value of 3/11/2001 at 12 a.m. is stored within that variable, and then we can go back and display it as needed. So, but for our purposes here, don't worry about the .parse. That's just a way of declaring the birthday variable, which by the way, all of these here are considered variable declarations. When you create a variable and give it a value, that's known as declaring it. So we've declared our variables here, and in this next section, we're going to display them. So let's run it. Okay, so now we've got it running, and we can see there was no input for this app. It just displays the information. So we can see student is Smith, John. They are enrolled. They're 21 years old, male. There's the date of birth with a 3.7 GPA. So that finishes up App 2 in our sample application. So let's go back. Okay, so that completes the first lesson in our Programming Fundamentals series. We now have the concept of variables, where we can have data that changes within our application. We're going to have hard-coded values, and then we're going to have the variables that can come from user input or a database or the cloud. They can be populated from wherever. And then those values can be used for logic and decisions within our application. So for now, that's going to do it. We'll see you next time.